Hey everybody, welcome back. We're in the next lesson called Permutations with Identical Objects. Last lesson was called Permutations with Distinguishable Objects. So what we're taking a peek at this time is saying, what are we going to do when we've got objects that we can't tell the difference between? So identical objects. Okay, earlier we looked at arranging the letters in the word gym. And if you remember, we could do that by going 3 times 2 by 1 using the fundamental counting principle. But the reason we could do that is because those letters are all the same. What we're going to do here is we're going to look at Bob. And the first thing I want to notice is I've got 2 B's that are the same. So if I try to list out all the unique ways that I could spell Bob here, that's it. I've only got 3 ways. Even though there's 3 letters, there's only 3 ways. So I got to figure out a calculation for this. So I'm going to, if this was in class, we'd spend some more time trying to figure this out. But since you're looking at this online, I'm going to cut to the chase. I'm still going to look at this like this. I'm going to say there's the fundamental counting principle tells me that there's 3 objects here. So I got 3 letters that could go in the first place, 2 letters that could go in the second place, and 1 letter that could go in the last place. Okay, well that would give me 6. And I know the answer over here though, is there's only 3 ways I can do this. So what I need you to notice is that there's a couple of B's that are the same. So what I'm going to do is I'm not just going to divide by 2 to get 3. What I'm actually going to do is I'm going to divide by 2 factorial. Why am I dividing by 2 factorial? Well, there's 2 B's, and I need to arrange them. So I'm arranging the 2 B's, right? If I want to think of it using fundamental counting principle, there's a B here. So there's 2 B's that could go there, and there's 1 B that could go in the last spot. But I can't tell the difference between them because they're identical. So I'm going to divide out my identical arrangements. And that's it. I get 3. Let's try this again. Okay, now we got Bill. Now, Bill, if I left you alone for some time and I said, okay, list all the different ways you could, it's a huge pain in the butt, even though we're only at 4 letters. So let's see if we can go right to the calculation. So there's 4 letters, so fundamental counting principle. 4, 3, 2, 1. Remember that letters can never repeat. They're like people. But now what I'm going to do is I'm going to divide out the arrangements of my repeats. Well, there's 2 L's that could go in the first spot, and there's 1 L that could go in the second spot. So what am I left with here, or what are we left with? That's 24 over 2, which is 12. This is also 4 factorial over 2 factorial. Okay, so if I had asked you to list that out, there would have been 12 ways. That's a bit of a pain. Now we get to Lil here with 3 L's. So again, my calculation, I'm going to start off with fundamental counting principle. So we've got a spot for each letter. There's 4 letters in her name. We're using all of them. So 4, 3, 2, 1. Now I'm going to divide out my repeats. Well, here's my L's. My L's are identical. Well, there's 3 L's that could go in the first spot, 2 in the second spot, 1 in the last spot. And so now what do we really have here? We've got 4 factorial over 3 factorial, which guess what is just going to be 4. So last one, D. Now it says have fun. Again, by now, even if you were in class, you would have figured out the pattern, I hope. So there's 5 letters in Lily. So 1, 2, 3, 4, 5. So 5, 4, 3, 2, 1. And I noticed this time that I've got 3 L's. So here's my L's. Okay, so here's my L's. And then I want you to notice that we've also got 2 I's that are identical. So I'm going to arrange my L's. 3, 2, 1. I'm going to arrange my I's. 2, 1. And now I'm just going to write this in a much simpler way. This is going to be 5 factorial divided by 3 factorial, 2 factorial. And you can go ahead and put that in your calculator. That's going to be 120 over 12. There should be 10 ways to do this. All right. So I'm hoping that you're seeing that every single time when I have an identical object, I'm going to divide out those repeats or those identical arrangements, and that's going to account for the fact that I can't tell the difference between them. Okay, so next page. When I've got identical objects, or we have identical objects, we're definitely going to have fewer arrangements because we can't tell the difference between them. This is because some of the arrangements are identical. Therefore, we need some sort of way to remove these objects. So the L's can be arranged in Lil here, 3 factorial, or 6 different ways. So what we're going to do is divide by this 3 factorial, or the 6, so that we don't count these arrangements multiple times, because I can't tell the difference between them. So in general, this isn't on my formula sheet. It's not like it's anything I need to remember or memorize, I should say. This is n. This is how many objects in total. And these are the number of identical arrangements. Great. Okay, so if we wanted to use Mississippi, oh, what a pain in the butt. Look at that. Okay, first thing I need to know is just how many letters there are in this crazy word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there's 11 factorial then for my numerator. But then I'm going to start looking at all my identical objects. Let's look at my S's. I see 2 S's, 4 S's. So I'm going to divide out 4 factorial. That's me arranging my identical letters S. Then I'm going to go to I. 1, 2, 3, 4. So I divide out that. Here's my arrangement of the identical I's. And then I got, what do I got here? P, 2 P's, 2 factorial. There's my P's that are identical. So there's my identical arrangements. And you know what? If we really wanted to, I'm just going to extend that line there. If we really wanted to, we could consider the M. There's 1 M. How many ways can I arrange it? Nothing wrong with putting that there. And then all you got to do is put that into your calculator. Okay, so again, this is us. There's our identical arrangements. Pretty cool. Makes that question a heck of a lot easier. Okay, last little section here is right here. So we've got these things, they're called pathways. And when we're looking at pathways, you're saying to yourself maybe, what the heck is this doing here? Doesn't look like anything I've been doing. Okay, here's how a pathway works. I'm always going from A to B. I'm always going towards my goal. So it says I'm going north or I'm going west. So here's what I'm going to do. I'm going to count how many ways I have to go north. Well, I could go north right here, and I could go north right here. So there's 2 ways for me to go north. Yeah? And then I'm going to say, how many ways can I go west? 1, 2, 3, 4. 4 ways for me to go west. I don't know when I have to go west. It doesn't matter, right? I just know I have to travel 4 different blocks going west. Then what I'm going to say is, how many ways can I move? Do I have to move in total? Well, if I went 2 north and 4 west, that means I had to go 6 moves in total. Okay, how does this help me solve the question? Well, I need to essentially arrange these things, how many ways I'm going to go north and how many ways I'm going to go west. So I know I have to do 6 moves. So 6 factorial. But I'm going to consider the moving north as an identical object. There's 2 factorial ways to do that. And I'm going to consider me moving west as identical objects as well. And so I'm going to divide. So again, here's my total, the 6 factorial. The 2 factorial is the 2 blocks I have to move north. The west is the 4 factorial. And then all I have to do is put that in my calculator. Now, there is another way to do that with just counting the pathways out, but I'm going to leave it like this for now. Okay, I'm going to look at the next question. I'm going to do the same thing. Now, there's this kind of this choke point here where I'm right in the middle. So I'm going to count this grid as 2 separate questions. So I'll do the top one first. Top one here says I can go north twice, I can go west twice, and I can go total, I need to make 4 moves. So that's going to be 4 factorial over 2 factorial, 2 factorial. This one here. Well, I'm able to go north twice again. This time I'm able to go west 1, 2, 3, 4 times. So total is 6. So this is 6 factorial over 2 factorial, 4 factorial. Now, what am I going to do with these 2 things? Well, what I'm saying is to get to this choke point right here, I get there and I keep going. Well, the word and means multiply in math. So guess what I'm going to do? I'm going to take these 2 answers and I'm going to multiply them together. So I'm just going to take a quick second to do that. The first one would be 24 divided by 4. That should be 6. And this one here, I'm going to pick up my calculator just because it's the last question and I don't want to screw it up. That's 15. So my answer to this question then is going to be 6 times 15, which sounds like 90. Now, there is another way to do that using simply just by counting the number of ways, but it can become a bit cumbersome. So for now, I'm just going to leave it like that. Okay, my friends, so what you're looking out for in this lesson when you're going through your practice is objects that are the same. Okay, hope that helped for you, and I will see you in the next one.